dy dx minus 3y over 4 equals minus 2y cubed e to the 2x. Everything's arranged in the correct order to make the substitution for Bernoulli's equation then. Y equals 1 minus n. The n value is here is 3. So we end up with y to the minus 2, or 1 over y squared, whichever we prefer. So let's get dy dx here. dy dx equals then, differentiate this, minus 2 over y cubed dy dx is what we've got here. So rearrange for dy dx then to make the substitution. Dy dx is y cubed can come up. The minus can just go over to there. So you've got y cubed with the minus, and then the 2's underneath, isn't it? Over 2 times dy dx. Let's just check that. The y cubed comes up, the minus can come over, so there, and then the 2 come from times down to divide on the other side. I've written it right to left. So dy dx equals that then. So here, so substitution then gives dy dx, which we can put in as this, minus y cubed over 2 dy dx minus 3y over 4 equals minus 2y cubed e to the 2x. Now we need to divide by y cubed all the way through. So let's turn our attention to this now. Divide by y cubed all the way through. I'll worry about the minus a half in a minute. So it's minus a half dy dx. And then we've got minus 3 over 4. The y cubed, one of the y's will cancel. We'll get 1 over y squared, which is v, equals minus, and then the y cubed will cancel here, and we'll just have minus 2e to the 2x. Now we need to times by minus 2 all the way through to get rid of that minus a half. So minus 2 times minus half is 1, so we can just write dy dx. Minus 2 times this thing here becomes a plus. One of the 2's cancel, and we'll get 3 over 2 times v is equal to, times this by minus 2, we get plus 4, don't we? E to the 2x. Now we've got an integrating factor method problem here. Separate problem now. So we can just mark off the p. And we can find the integrating factor. So here, the integrating factor then, e to the integral of p, 3 over 2, dx, which equals e to the 3x over 2. There's our integrating factor. So e to the 3x over 2 then, times dy dx, plus 3 over 2, the e to the 3x over 2 I'll put in the middle, times v, equals 4. Now e to the 3x over 2 times by e to the 2x, you just add the powers, the indices. 2x and 3x over 2 is 3.5, isn't it? 7x over 2. Okay, so that's what we've got then. Let's circle the u and the v before we write down the next line. So here's u and here's v. They're always in these positions. So this implies then, whoops. This implies then d by dx of u times v e to the 3x over 2 times v is equal to this thing over here, 4e to the 7x over 2. Now let's turn our attention to this problem. So integrating both sides then. So integrating gives the integral of the derivative is just e to the 3x over 2 times v equals 4 lots of the integral of e to the 7x over 2 dx. Integrate that then using standard integrals is e to the 7x over 2 over 7 over 2. So the 7 can go down there and the 2 can swing up to be here. Plus k. So we end up with 2 4s are 8, 8 sevenths e to the 7x over 2 plus k. And now we can just, what we can do is times by e to the minus 3x over 2. Or in other words, divide by e to the 3x over 2. So we're going to times by e to the minus 3x over 2 through the equation, and this will cancel this because you just get e to the 0, which is 1, so we get v equals e to the minus 3x over 2, just because they're times, you add the powers. 7 over 2, take 3 over 2, so you end up with 8 sevenths. 8 sevenths times by e to the 2x, isn't it? Back to e to the 2x, plus k e to the minus 3x over 2. Oops, that's v. So v at the outset we said was 1 over y squared, I think, wasn't it? Let's have a look. It might be. I think it was 1 over y squared. Yeah, there it is there at the top. So we need to put that in. So that's what v equals then. So that implies 1 over y squared equals 8 sevenths e to the 2x plus k e to the minus 3x over 2. So invert it. Y squared is 1 over 8 sevenths e to the 2x plus k e to the minus 3x over 2. So I've just inverted this fraction, put a bracket around it. I'm going to square root it all in one fell swoop. So the square root of this side will equal the square root of this side. Plus or minus. There we go. So we inverted it, and then we square rooted. You invert this, which is here, and then you square root it, which we did, plus and minus. There's y. Good.